In this video, I'll go through the rules of naming a cycloalkane that has multiple substituents. So one thing about naming cycloalkanes with multiple substituents, you want to make sure that you give each the lowest number possible. This is determined by identifying the lowest set of numbers. So we'll go through the rules and I'll point that out in just a minute. So as with other molecules, the first step is to identify your parent chain. One thing that you want to make sure that you make a note of when naming cycloalkanes, you count the ring or you count what's outside of the ring, but you cannot combine the two. And so what I mean by that, so if we look, we have carbon atoms in a chain outside of the ring, we have our ring. So what I cannot do, I cannot say 1, 2, 3, 4, 5, 6, 7, 8, 9 carbon atoms in a continuous chain because that's not the case. I can only count these two outside of the ring, this one outside of the ring, this one outside of the ring, or the 6 in the ring. So I have to count them separately, either what's in the ring or what's out of the ring. So in this case, my longest continuous chain of carbon atoms would actually represent those 6 carbon atoms that are in the ring, and so we have the name cyclohexane. Cyclo tells us ring, hex tells us 6, ane lets us know that it only has carbon-carbon single bonds. From there, we want to identify substituents. So I can see 3 branches sticking outside of my ring or my parent chain. This one branch has 1 carbon, so it will be a methyl group. This one branch contains 2 carbon atoms in a straight chain, so it will be an ethyl group. Then this one contains 1 carbon, so it's also a methyl group. So I have 3 substituents, but I need to identify where these substituents are located. So I need to number my parent chain. When numbering the parent chain, again with multiple substituents, I need the lowest set of numbers. So what I would recommend, and because you're dealing with a ring, any carbon could be carbon number 1. So I recommend that you look at what would happen if each carbon is carbon number 1, and then count in both directions. Because just as a ring, just as a chain or an alkane chain, rings can be counted in multiple directions. So you can count your ring in the clockwise direction or it can be counted in the counterclockwise direction. But you want to count whichever way will give the lowest sum of numbers for all substituents. And so again, I would just start at each individual substituent. So for instance, I can start at this bottom methyl and I would count both directions. So if I started here and just said, okay, this is going to be carbon number 1. If I counted clockwise, letting this methyl be carbon 1, this would be 2, 3, 4, and 5. So I would have a methyl at 1, a methyl at 4, and my ethyl at 5. But I could have counted counterclockwise. Starting here at carbon 1, then this would have been 2, 3, and 4. So then I would have had my methyl at 1, my ethyl at 3, and my methyl at 4. I can do the same thing with this ethyl. I can go clockwise, I can go counterclockwise, letting this be position 1. If I go clockwise, this is 1, 2, 3, 4, 5, and 6. So I would have my ethyl at 1, a methyl at 3, and another methyl at 6. But I could have also gone counterclockwise. So still letting this be 1, this would now be 2, 3, 4, and 5. So then I would have 1, 2, and 5. I can do the same thing with this top methyl, clockwise and counterclockwise, letting that position now be carbon 1. Clockwise, if this is 1, then that would be 2, 3, 4. So I would have a methyl at 1, ethyl at 2, another methyl at 4. But I could have also gone counterclockwise. 1, 2, 3, 4, 5, and 6. So a methyl at 1, a methyl at 4, and an ethyl at 6. When you get comfortable with this and you get more practice with it, you'll start looking and noticing little tricks. Where you have substituents closer together, chances are one of those carbon atoms will be carbon number 1. But because there's no true beginning or end in a ring, any carbon could essentially be carbon 1. Once you go through and you determine these different sets of numbers, simply add them together and figure out which set gives you the lowest sum of numbers. So if I add 1, 3, and 4, that equals 8. 1, 4, and 5, that equals 10. 1, 2, and 5 also equals 8. 1, 3, and 6 also equals 10. 1, 4, and 6 equals 11. and then I have 1, 2, and 4, which equals 7. So 1, 2, and 4 gave me the lowest sum of numbers. So that indicates how you want to number your parent chain. So I want to start at this top methyl and count in the clockwise position, numbering my cyclohexane ring. From there, that indicates where each substituent is located. So that means that this top methyl is located on carbon 1, my ethyl is located on carbon 2, and this bottom methyl is located on carbon 4. So I've now identified my parent chain, I've indicated and identified all substituents and where they're located. Now you want to put everything together. When you're putting the name of the compound together, you want to add your substituents first and then the name of the parent chain. However, when you're adding the substituents, a couple of things to take into account. One, you want to make sure that you put those substituents in alphabetical order. So I have methyl, ethyl, and methyl. So you want to look at comparing the M to the E. So of course E comes before M, so I would name the ethyl first. Another thing to look at, you have two of the same substituents. So you have two methyl groups. Instead of writing it as 1-methyl, 4-methyl, instead you would show it as dimethyl. This di means two of the same. So writing dimethyl indicates that you have two of the same, so two methyl groups. And so when you have those substituents, you have multiple of the same. You may have dimethyl, you may have trimethyl or tetramethyl, so on and so forth. If you have multiple of the same substituents, you still only use the name of that substituent to determine alphabetical order. So even though D comes before E, that's not the name of the substituent. The name of the substituent is actually methyl. So I have to look at that M. And so again, you want to put it all in alphabetical order. And then put it together to give the name of the compound. So when I do that for this one, I'm going to have my ethyl first, and I have to make sure I indicate where everything was located. So I still need those numbers. So I have 2-ethyl, and now that I have dimethyl, I have to indicate where both methyl groups were located. One was on carbon 1, the other was on carbon 4. You separate numbers from one another using a comma. Separate numbers and letters using a dash. And so you still write it all together as one long word with no spaces to give the name of this compound, which will turn out to be 2-ethyl 1,4-dimethyl cyclohexane. Anytime you have to use that di or tri or however many of the same substituents are represented, you have to make sure that you have the same number of numbers to indicate where they're located. So the same number of locator numbers. So I had dimethyl, which that di told me 2. So I need 2 numbers to indicate where both of those methyl groups are located. So again, the name of this compound is 2-ethyl 1,4-dimethyl cyclohexane.